All right, what up, you guys? Last question forever. So we have this question kind of touching on chapter 12. So we have just one atom, right? Single atom, only one, traveling at 1% the speed of light, and we are given its wavelength. That seems normal, but we're asked what element it is. So that kind of makes it a little bit more challenging. We've kind of done a lot of questions like this where asked us to identify the element. You can really answer this by finding the molar mass, or by finding the number of protons, or maybe by finding the electron configuration, right, if we're doing later chapter 12 stuff. You just have to figure out for each question, so which one is it setting you up for? Are you going to find the molar mass? That's unique to every element. Are you going to find the number of protons? That's unique to every element. Or are we going to find the electron configuration? That is also unique to every element. Right, we're also given speed or velocity, and we're also given wavelength. So do we have any formula with either mass, number of protons, or electron configuration? Right, you might be thinking about a couple formulas here. So we have the de Broglie wavelength. I'm gonna write de Broglie, right, which has h over mv, where m is mass in kilograms, and v is velocity, where h is a constant. So we're given wavelength, we're given velocity, we know what h is, so this would help us find the mass. So that's a good start. Also, we probably can't find the number of protons because this isn't really about like protons, charge, or anything, so that probably won't work. It's also probably not about electron configuration because we're not given any information about the electrons or where they're occupying. So you could also do this by process of elimination, being like, well, the only thing that I could really find here is molar mass. The other two are too unlikely. So when in doubt, identify by finding molar mass. Cool. And I just want to compare this wavelength formula. Let me get rid of these guys. I want to compare it to a different wavelength formula. So we also have wavelength times frequency is equal to c, the speed of light. So how are these formulas different? This one is good for things that travel at the speed of light, which is anything without mass. So this is used for EM radiation, so for electromagnetic radiation. So this is for stuff like light, wavelength. So stuff without mass can move at the speed of light. The second, though, you have something with mass, you can no longer move at the speed of light, which is why we have velocity here instead of c, the speed of light. Right, so you want to use the de Broglie wavelength formula for anything with mass. So used for things with mass. Right, so it's kind of cool. So it's cool to think about anything that has any mass at all, and anything that is moving at any velocity technically has a wavelength. So like you and I have a wavelength, which is cool. And you could even calculate it if you wanted to, but I will let you do that on your own for fun. So yeah, let's use the de Broglie wavelength formula and let's figure out what element this is. All right, so we already know our wavelength. I'm actually going to rearrange it. You can go ahead and plug everything in as is. I'm going to rearrange it to make mass be our answer. You don't have to do this, but h over m to v, so just rearranging formulas. Maybe that is your style, maybe it's not. To be our speed. Notice it's, by the way, another thing I was going to point out, the velocity looks a little bit different than frequency. So let's plug this guy in, plugging in h, and we're going to talk about the units of h too. 10 to the minus 34 joules times seconds. All right, so it helps to remember, I'll write this up here, where's our formulas? 1 joule is 1 kilogram times meter squared over second squared. So anything with joules in it has to have mass in units of kilograms. I'm actually going to write down the composite units here. So we got, this is joule kilograms times meters squared over second squared times seconds. Okay, cool. And we'll see how this helps us out as we go through this question. Continuing to plug things in. Right, so one thing that's a problem is our wavelength. Right, it's not in units of meters per second, not in units of meters, it's in picometers, so we have to convert it. That's okay. Again, letting the units guide us. So we have 10 to the 12 picometers per 1 meter. And then we have our velocity. It's not given to us directly, but we know it's the speed of light. So 3 times 10 to the 8th meters per second. And it's 1%, so we have to multiply that by 1% or 0.01. All right, cool. So now we can see where the units make sense. So let's cross out everything we can. Right, picometers, that was just our conversion. One of the seconds cancels out with the seconds here. Then we also have the seconds canceling out from our velocity. One of the meters cancels out from our wavelength, and the second meters cancels out from our velocity. So that's what's kind of cool about understanding like the units of joules, is you understand why you plug kilograms into the de Broglie wavelength formula, why you use kilograms. And that really applies to like anytime you have any formula with joules in it, you want to be plugging in your mass in kilograms. For that reason, our mass ends up being 6.67 times 10 to the minus 26 kilograms. That's great. It's also helpful to remember is this is the kilograms of what? Like what even is this? This is the kilograms of just one atom. So I'm going to actually add that to the units. This is the kilograms per atom. And again, just focusing back on what we want to find. What element it is we want to identify by finding the molar mass, which is grams per mole. So let's go ahead and do that. We almost have grams per mole. We just need to work on the units. So we know that 1 kilogram is 1,000 grams. And we know we want to have moles on the bottom, grams per mole, and we know we want to remove atoms. So since atoms is on the bottom here, if we want to remove it, we put it on top here. So we know that 1 mole is 6.022 times 10 to 23 atoms. Let's go across our units to make sure everything is fine. Kilograms, kilograms, atom on bottom, atom on top. The only units we're left with are grams per mole. And did we get something reasonable, right? We get 40 grams per mole. That makes sense, right? We've seen molar masses like this. If you're to get something like 0.0005 grams per mole, what does that mean? This means you did something wrong, right? So make sure you're getting an answer that kind of makes sense. You look at the periodic table, and this is calcium. All right, cool. So I hope that this helped you a little bit with the whole de Broglie wavelength versus other wavelength formula things, and I hope you understand more about the units of joules and how to identify elements.